Welcome back to another episode of Science Nights. I'm Josh.
I'm Adam.
And I'm Garrett.
And we are here today to talk to you about the great study and field of physics. Physics. He didn't join us in the physics.
You're supposed to
Now,
join.
I was going to, but then at that point I felt like I couldn't do it. So
Too busy laughing now.
So the goal of today's show is to give a brief overview and history of physics, as well as talk about some of the things that we enjoy most in the world of physics. And something we should note as we branch further and further into the different disciplines of science is these are all interconnected.
definitely.
Something that
sure.
Stephen Smith pointed out to us and we should have mentioned long ago.
Is extremely interconnected.
I think we kind of have a little bit.
Well, with astronomy we have, and
like astronomy and chemistry and how that all intertwines. Physics is can be the underlying science in a lot of those. You know, it's
Yes.
how matter moves and acts in the universe. So.
Sure. It governs the movement of subatomic and celestial bodies.
Mm-hmm. Absolutely, it's from astrophysics to quantum physics. So.
Yep.
That's why physics is there.
Yeah.
Physics. The physics part.
But just for a clerical definition of physics, it's a branch of science concerned with the nature and properties of matter and energy. The subject matter of physics, distinguished from that of chemistry and biology, includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structure of atoms. So all of those are interconnected with biology and chemistry and
right.
astrophysics and all of that stuff. But like
Quantum
Adam said,
physics.
this is like the underlying.
Yeah.
Very, very much the base. I feel like the grandfather, you know? Like, I don't feel like physics was the first one to be studied, but...
No, but it's a way to explain the mechanics of things and figure out the mechanics of
and
things.
makes
So.
other sciences relatable to other sciences.
Right.
I feel like it's good almost language, you know?
Right.
That you can use across them.
Well, speaking of languages, science is absolutely a universal language. We'll start off in Italy, where a lot of the scientific revolution started, and we're going to talk about the history of science, starting with Galileo Galilei.
Smart guy.
We've talked about him before on
Astronomy.
Yeah. We talked about him before, I think, on something else. But Galileo comes up a lot, just like a couple of the other people are going to come up a lot.
Eventually, we'll just have to do an episode just on him.
Yeah,
That would be sweet.
As I described in the astronomy episode, I really enjoy Galileo's life story because it's so hampered by him railing against what was believed at the time.
Yeah.
They eventually put him under house arrest as a heretic.
Yeah.
But as far as his relation to physics goes, he was the first one to theorize the motion of celestial bodies.
That we weren't just hanging out.
That they weren't like pinholes in a glass dome that rotated over the, you know.
Well, he built upon the Copernican model of celestial movement and then moved on to create his own, finally defining the heliocentric solar system. Mm-hmm. But his work, I mean, not only is it in astronomy, but it's in like we talked about how physics is an important part of celestial motion.
Yeah.
He figured that out. He delved further into the mathematics of trigonometry and geometry, and was probably one of the most instrumental people in the scientific revolution.
Definitely. I
Hell of
agree
a
with that.
thinker.
Yeah.
Right?
Like, just imagine, like, trying to think outside of the box that far.
To go against that many people's
Exactly.
like just regular everyday thought, you know.
Yeah.
Like, of course that's not true. Of course we're the center of the universe.
And you're like, no, I can see it. I can see it. I'm looking up and seeing it right now.
Jupiter has 4 moons at least.
Right? I'm going to name them.
From there, we're going to jump over into jolly old England, into the 1600s, and we're going to meet up with a guy that we've talked about before on biology and I think on chemistry or astronomy, Robert Hooke.
Yeah, good old Robert Hooke. Because he did the cells, right?
He did cells, but he also was like instrumental to Newton's work.
Yes. Yeah.
So Robert Hooke, as you can see on the image that I've got here on the screen, nobody really has an image of him. He's described as a curmudgeon, as bent, as dastardly. He was kind of known for like stabbing his friends in the back a little bit.
Oh, okay.
But he was also like an egomaniac. So that's why when he discovered the law of elasticity, he pushed really hard to name it Hooke's law. Which is important. I mean, that's allowed. That's what science is. That's part of science, right?
I guess.
You to name what you discover. But this guy is the one who developed the law of elasticity. Like he said, if force F is needed to extend or compress a spring by some distance x, then the amount of force is proportionate to how much distance you have to go, and it's essentially how much force you're going to be given back. But this elasticity still holds true today over the course of things that you can think of, like right in your own household. There's a bass guitar over there, and the strings on it have to obey the laws of Hooke's elasticity.
Yep.
Absolutely. Even a like a bridge swaying in the wind.
Very tall
Something along
buildings,
those
yeah.
lines. Very tall
Exactly.
buildings.
The farther and farther it leans, the more force it's going to take to lean it any farther.
Right.
So the guy was a jerk, but he's probably a genius too.
Well, yeah.
Oh,
I mean,
absolutely. I mean, basically it comes down to him and Newton didn't get along.
Exactly,
Newton
right?
was a little more famous, a little more popular. He was the what was he? The Royal Society?
Yeah, they're both the members of the Royal Society.
Yeah, but he was like in charge of it at the time.
Newton became
by
the president.
end of it. Yeah.
ah,
And then yeah.
the politics of science.
Yeah, it's not unheard of. The Britons are all about class, right? Like,
Hey.
especially back in this day.
Not even just them.
One thing I wanted to bring up with the elasticity is as we start building things in space bigger and bigger, Hooke's law is something you would have to think about, right?
Oh, yeah.
'Cause if you had a starship that was so huge that it becomes
would
flexible, then,
yeah.
based on length.
That would be terrible.
You can also see that in shipwrights, like wooden shipwrights.
Yeah.
Right, absolutely.
That ship that Bill Nye talked about in his debate, the Discovery, I think it was called.
Yeah.
It was so long that it had four main masts, and it flexed and bent
Right.
as it sailed,
It
and it
puts a-
sunk.
It puts a
And
hard
it's so-
limit on the materials you can use. Then.
Yeah.
Exactly, and that's actually where the start of metal ships started to come around.
Right.
Because that's how we got, like, the Titanic and the Queen Anne and things like that. These large behemoth things, but they're made of metal because they can withstand the elasticity.
Yep.
Whereas wood goes wobble, 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 snap.
Yeah, right.
Pretty much.
I can only take so much of this.
I wish I was a tree still. Moving on from bent and crooked old Robert Hooke, let's talk about Sir Isaac Newton.
Here it was ugly.
Isaac Newton?
No, Hooke.
Oh. I mean, there's not a part of physics that you can't talk about Newton for.
Yeah. Honestly.
Motion, gravity, like the mechanics of things. What else we got? We got electromagnetism, somewhat.
Yeah.
His work in astronomy. Oh yeah, and then he created calculus.
Calculus is math plus time.
Definitely extremely important to the to physics.
Yeah. Absolutely.
Dealing like his laws of motion is how you can relate physics to our everyday lives.
yeah.
Things that you
Gravity alone, it's the basis that you need if you're going to be doing any sort of physics experiment on Earth because it's affecting you.
Right.
Like, you have to account for that. You can't just do things in zero gravity here on Earth, or really anywhere. There's
Right.
still microgravity.
Yeah.
But-
you're still being influenced by something. You'd have to go
Exactly.
really far out.
Really far.
Way in between galaxies.
Yeah. So
Can you guys name one of the laws of motion, just off the top of your head?
an object in motion stays in motion.
Yep. Every object
At
in
the
a state
same
of
velocity.
uniform motion tends to remain in the state of motion unless an external force is applied to it. That's
Right.
the first law.
Yeah.
Object at rest will remain at rest. That's the
Yeah,
opposite.
and
Right.
every
For every action, there's an equal and opposite reaction.
Right.
Yep.
Yeah.
Yep. That's another one.
Yep. I don't know. It's just fun to think about from time to time. Just
Yeah.
like, hey, do you know the Pythagorean theorem off the top of your head?
A squared plus B squared equals C squared.
Right? That was
Oh,
drilled
okay.
into you
Yeah,
in mathematics class, right? And I'm never going to forget that.
Right? I've actually used it a few times.
Me too.
Though, is the funny thing.
Yeah.
Like, a lot of people, and it's just random everyday stuff, mostly Dungeons and Dragons, really.
Yeah, where you're mapping out a distance.
Yeah, you're like,
Yeah.
how far away am I? So I'm at a 90-degree angle. Oh my god, I get to use Pythagorean theorem. Like,
I think it was at one of those games.
yeah. Can we see this guy off the cliff? What if I fly up? Yeah.
But it was the work of Newton that would later be the groundwork for Einstein's stuff.
Mm-hmm.
So we'll get into that later. But I think the most important thing I think Newton did was he made calculus. He made. I know it's a really crappy thing to say, especially to students, but he taught us how to describe the world around us through math
And quantify it. Yeah, absolutely. It's the basis
Yeah,
of a lot of scientific discovery.
We still use equations he's come up with today for lots and lots of things,
including like launching spacecraft.
Yeah, making some of the amazing like gravity assists that we've seen them do, where like it flies around Jupiter and then you know, all based off the same equations that he came up with hundreds of years ago.
So remember how we were saying that like Robert Hooke was probably a genius. This guy, Newton was probably equally or more of a genius than him.
Yeah.
It's
and also a little bit crazy.
Look crazy, yeah. I don't know.
I think it comes with the territory.
I think so too.
Especially at a certain age, you know.
At least eccentricity.
Oh yeah, absolutely.
That's just bordering. That's just crazy in a polite name.
Even modern day, like you go on YouTube and look at like mathematician videos, like awesome. Those are some hilariously eccentric dudes that are really about math.
Yep. Number File.
I love Number File.
If you're ever interested in seeing in math being interesting, if you're not generally interested, if you're not a mathematician, check out Number File on YouTube.
Yeah, there was an episode they did about Klein bottles that guy was so obsessed with the Klein bottle that
What's a Klein bottle?
It's a 4-dimensional object that has one side. So it's like a Mobius strip if you extended it around.
Yeah.
Gotcha. Okay.
Is it Klein model or bottle?
Bottle. Bottle. It's
okay. Yeah,
So-
these are freaking crazy looking.
they don't intersect at any point in a 4-dimensional space, but they're pretty he makes hats out of it like
Yeah, it's a
he's
Mobius strip. I'll put a picture up for you guys.
Sweet. Thank you. But yeah, there's an awesome episode, and that dude is so eccentric, and I feel like it just comes in the territory.
Sure. Yeah, he's got a hat. He's got a freaking beanie.
His Klein bottle
Little
beanies.
Klein bottle beanie.
I'm telling you, he's a weird dude.
Yeah, that's awesome.
Yeah, but he loves math and science. Like,
but like moving on, we got to move on. We got to get out of Isaac Newton territory and get into Michael Faraday. Yep, he's the man who decided to put electricity through a magnet and discovered electromagnetism.
Yeah,
which we use regularly
all over computers every day. Like all sorts of electronic devices that move things. You know, use
maglev trains in Asia. Those things are awesome, and they never touch the rails. Those are awesome.
He created the Faraday cage, which we use microwaves. Use that technology to contain their electromagnetic spectrum.
Laws of induction.
It's also the same. Faraday cage is the basic idea of why if you got struck by lightning in a car, you wouldn't get electrocuted because it diverts the electricity around you.
Correct.
And then down eventually into the rubber of the tires, right?
No, actually, the rubber of the tires have nothing to do with it.
No effect, really? Okay, I didn't know that.
Your tires are so thin compared to how much electricity, how much lightning can arc.
Sure.
It's not It's
It would
more.
probably arc, yeah.
Yeah, it has nothing. It's a common misconception that the tires are what keeps you safe.
Gotcha. It's the Faraday cage.
It's the fact that
principle.
the car is basically a Faraday cage.
Yeah, it's more conductive than you are.
Right.
You know?
It diverts the electricity around you instead of through you.
Yeah.
You know, I was just thinking. Now we're talking about cars, and we were just talking about Isaac Newton and inertia. We experience inertia on a regular basis when we drive.
That's
And
definitely.
you don't
stop to a move.
Yeah, exactly. And you don't feel the catastrophic versions of inertia until you're in a car accident.
Yes.
Yeah.
That's
Going
what-
from 60 to 0
Yeah, like
is
that.
is not so bad when it's done over 5 seconds versus when it's done
Right.
over 0.5 seconds. You know.
Exactly.
That's a good. I mean, I know it's a little further down. That's a good example of relativity too.
Yes.
Is because you're moving. That's why you could be inside of a car and like flipping a coin
Yep.
up and down and catching it because it's moving at that 60 miles
Exactly.
per hour too. So from your perspective, you see it just being thrown straight up in the air and coming straight down.
But a
But from
bystander-
somebody on a different perspective,
Relative perspective. Yeah.
right, is seeing everything moving at that speed.
Yep. Exactly.
Just real quick to wrap up Michael Faraday, not only was he really cool in developing the Faraday cage and electromagnetism, but he also went around doing demonstrations of this just for the public.
Yeah.
Like, Bill Nye considers him one of the first science communicators. And by that, he
Definitely.
just means, like, everybody needs to know this stuff.
Didn't
Right.
his stuff like base the groundwork of like electric motors?
It's
as well?
possible. I would
I wouldn't
doubt
be
it.
surprised. Yeah. Yeah.
Those motors work off of induction, correct?
Yeah.
Yeah, so I would imagine so. Like he's one of the
It's
reasons that we
it's
have.
like the first step towards
Yeah,
it, right?
exactly.
Yeah, definitely.
So it's the whole reason we'd have Teslas, I guess.
Well, I mean, speaking of Teslas, we can talk about the man, Nikola Tesla. I picked him and not Edison just because I like Tesla a little bit more, but Edison definitely does a lot
Edison
of work.
was a salesman.
I know.
Right. Edison's been known for taking a lot of those ideas and just rebranding them, basically. So
Sure, but we highlight Nikola Tesla because he's the one to create the first alternating current system, AC
Right.
versus DC, direct current. So that's AC/DC's logo is now, you know why. It's alternating versus direct. So Nikola Tesla is known for the contribution in the development of alternating current. He worked very briefly with Thomas Edison and George Westinghouse, but his experiments on high voltage electricity is what really made him famous.
right.
Death rays and
Yeah.
He
You know,
wanted
Tesla
to
coils.
he wanted
Tesla
to like
coils.
wireless electricity, basically.
Yeah,
like
wirelessly
pump
power
electricity
things.
into the atmosphere.
Yes.
So we could just harness
Just
it.
draw it
yeah.
from our atmosphere. Yeah.
If I'm not mistaken, he was also pretty crazy.
absolutely very eccentric.
So, and I think there's some conspiracies too with what happened to him or how he died. If I
It's like
I'm
it's like the Teamster guy, Hoffa. Like,
Right, yeah.
It's like
Teamster
Tesla.
guy, yeah, that's what he was. He was a Teamster guy. That's I like
Just
that
title.
one.
We call people by their titles.
Yeah,
hey, man,
Teamster
that was
guy.
the strongest the Teamsters have ever been.
Yeah, absolutely.
But obviously, so harnessing electricity and using it for higher voltage stuff. That's Nikola Tesla, and then you have Edison right next to him doing direct current stuff for lower level electricity. I think it also deals with how that electricity is distributed. But I don't really know how AC works versus DC.
You
So
got me.
AC is flipping its poles,
Okay.
positive and negative.
Okay.
So that's why it's alternating current versus direct current.
Which is just always from a positive to a negative.
Right. Yeah.
Got it.
Like a battery. You
Okay.
always have a positive terminal and a negative terminal.
Got
That's
it.
the reason why you don't have to like. There's polarized plugs, right? So like you have one plug that's bigger
Yeah.
than the other, but you also have stuff that you can just plug in either way.
Yep,
Doesn't matter.
I see, because it's alternating current.
Right. And then there would be a converter or transformer or whatever inside the electronic that would convert it into direct current.
To be usable.
Yeah.
I see. Alternating current just travels better.
Alternating current is so we can send it miles.
Got it.
So when you see power lines, are those alternating current?
Yeah.
Yes.
Yeah.
Okay, cool. See, we learned something today. That's one of the things I love about this show is we always
Right?
learn something.
And I did not look any of that up beforehand, so if I'm wrong, please let us know.
Yeah, absolutely.
Yes,
Because we're
peer
basing
review.
it.
Yeah.
Peer
We're
right.
basing it off of Adam.
Big part of science.
Moving on from Nikola Tesla, though, we have to talk about the Madam Mary Curie. I'm going to call her that now, Madam Curie. From now on, she won 2 Nobel Prizes. We talked about her with chemistry, but her first Nobel Prize was in radioactivity. She discovered radiation. So she discovered that isotopes over time shed their neutrons and shed electrons and
As
are
energy,
radioactive
yeah.
and poisonous. Garrett brought up before we started, like, didn't she die of radioactivity poisoning or radiation poisoning?
Yeah,
And I was
radiation
like,
or cancer or something. Yeah.
She did. Her equipment is still very, very, very much
Yeah,
radioactive.
it's still considered
believe it.
radioactive waste. So
It's not waste. That's science, science history.
But I mean,
it will kill
we
you
wouldn't,
though.
Yeah. I'm
we
not
wouldn't
saying
be
that.
able to handle. We wouldn't be able to utilize and see other versions of light without her work.
Yeah.
in the radioactive spectrum. Like for instance, X-ray. Like we
Yeah,
wouldn't have X-rays.
Absolutely, yeah.
And X-rays are critical, are a critical piece of technology for modern healthcare. What's the first thing that they do if you have a problem with a joint? Get in the X-ray.
Right? Go stick your arm in there.
I mean, your dentist.
Blasted with radiation.
Yeah.
Your dentist.
Let's cover the
still-
rest of you with a lead jacket, though.
Yeah.
Exactly. Yeah. Your dentist still puts a lead jacket over your vital organs, and then you still.
I appreciate that.
I do. Like they're taking care of me. They are.
We'll be on the other side of the glass in a different room.
It always makes me want to
Exactly.
fall asleep, though. I'm just like, oh, this is so heavy. And
Right.
nice.
Like compression.
Yeah. I need one of these for at home.
But yeah, let's all thank Mary Curie for discovering thorium, polonium, and radium and radiation.
Thank you.
And last but certainly not least, and I'm sure there's more, and we could talk about him for days, but Albert Einstein. Obviously, first we have the picture, the famous one of him with his tongue out.
Oh yeah. Okay. Yeah.
But then other than that, let's look at Einstein when he was actually in the early 1900s discovering stuff.
He was much younger.
He was. Thanks, Garrett.
Got it.
But at the age of 17, Einstein enrolled to complete and receive his teaching diploma in the field of physics and mathematics at the Swiss Federal Institute of Technology in Zurich. He debated with Niels Bohr and the other founder. He debated often with Niels Bohr, who was the other founder of quantum mechanics. And then in 1905, Einstein published On the Electrodynamics of Moving Bodies, and it contained his first theory of general relativity. In 1921, Albert Einstein was the recipient of the Nobel Prize in the field of physics.
Earned it.
Yep.
Earned it.
No kidding, though. This guy came up with general relativity, the E equals MC squared calculation, special relativity, and just crazy physics, man.
Yeah.
The black holes that have been discovered in the last 2 years were predicted by him. He's
Wow.
like, if
They've
the
gotta be
world and the universe works like we're supposed to believe it does,
Yeah.
then these two should be somewhere.
He
Found
got almost everything right. So some of his biggest mistakes was like underplaying our abilities. So like he predicted, or he proved mathematically lasers, but was like, we'll never be able to do it. Or also, what was it, gravitational waves? When we detected gravitational waves,
yeah.
a couple years ago, a year
Yep.
ago or
Yeah.
so.
That's what I was talking about when I meant like, because there was all those pictures of where Einstein's statue is, and it's like, I'm right, I did it.
Right.
Yeah.
He predicted that, but also at the same time said we will never have equipment sensitive enough to measure it, so there's no way to really tell for
Yeah.
sure.
If
you
I'll
know?
ever be right
So
or not.
that was the only thing he was really wrong about.
Yeah.
Was our ability
advancement.
to right. So it's pretty amazing to get that.
Well, we have him
That
to thank for
correct,
that type of
you know.
advancement, you know?
And a lot of his like he was very into things need to be in their most simplified form. You know, that's why the whole like E equals MC squared equation is so famous.
And
like,
so small.
right, exactly. He figured that
One reason
if he came up with like this huge, really complicated equation, it was probably wrong. You know, that nature works on a much simpler basis. You know, not simpler, but basic.
Reduced,
You know?
yeah.
Right. And special relativity is another thing we use every day in like our GPS systems, our GPS satellites.
Oh, yeah.
Well, mine's been getting it wrong because it puts me in other cities.
They have
Rough.
to adjust for our GPS satellites have to adjust for special relativity because they're farther enough away from Earth's gravitational well that their time is different.
Yeah, time would affect it much
Time
differently.
dilation.
Odd, yeah. I mean, I guess when you're that far from the Earth,
Yeah.
the,
And I mean it's fractions, microseconds.
but I mean,
you know,
it would take you longer.
but the
you know?
GPS system has to be 100% accurate.
Yeah,
That's why it has to
exactly.
take that into consideration.
Especially because it'll be up. That satellite's going to be up there for a
Ah.
long time, hopefully.
Yeah.
You don't want to be replacing those every 2 months.
Well, our GPS system was originally put up there for the military, so there. Yeah.
Scientific exploration within the last 100 years is pretty much all
Right.
for the military.
He's not wrong. That's
Yeah.
who foots the bill.
Yeah.
I mean,
Exactly.
Well, that's
yeah.
where the money goes.
Yeah,
you know,
exactly.
I mean,
Which is odd because we're seeing that dynamic change now, right? With so many companies going into like SpaceX and
Or Blue Origin.
Yeah.
Yeah.
Like private
Virgin Galactic.
private companies going into space travel now.
Yeah.
which is interesting to see because
Well, they don't pay taxes, so of course they're not going to be funding. Oh wait, there's different,
Yeah, yeah.
different stuff. Different. It's not politics.
That's for another podcast.
Yeah. So I mean, obviously,
I'll join
that's
you on
our-
that one though.
Yeah. Obviously, that's all. We should get Tony Flink in here too. And Crazy Ed too.
Oh man.
That's our rundown of physics for today. But before we leave, we want to talk about kind of what gets us going about physics, what we find most interesting about it, and we'll go around just the guys. And what do you think?
Using physics as a prediction tool.
Yeah, damn it, that was mine.
Really?
You guys can have the same thing.
I think that is so incredible. What we can predict through physics. Like, we can literally go, this is how our solar system is going to look in 10 years, in 20 years, in 50 years, in 1,000 years. And we can predict that within a small margin of error, you know? I think that is incredible.
Definitely.
That's incredibly powerful to be able to do. I mean, you can't do it in your head. You have to have a computer do it for you.
A great
but-
example of that is the solar eclipse that we just had.
Yeah.
That we had in August.
Absolutely.
That was predicted decades ago.
Oh, yeah.
We knew it was coming.
Yeah, and the next,
Yeah, and we
100
know about the
eclipses
next one.
are
all
can be
planned,
calculated too. Absolutely.
and it all falls into line, you know? I think that is just awesome.
Physics
Yeah.
as a predictive tool is probably one of our most powerful weapons as a species.
Definitely.
And I don't mean weapon. I guess weapons is a bad choice. Our
Tool.
most powerful tool.
Yeah.
Like you might have a really cool Makita. We got physics too.
Yeah. I mean, physics makes the Makita work.
Yeah.
You know, whether it's a power hammer or a drill, you know, induction turns the brushless DC motor that spins your machines and whatnot, you know?
Yeah.
Like, it's all physics. It's all around you.
I think it's all around you and it's demonstrably around you.
Yes.
You don't need to have like a lab
A
to
physics
demonstrate
demonstration.
physics.
Right.
Yeah, go bounce a ball. You know?
So that's my favorite thing. Basketball is entirely physics and calculus.
Yeah.
And that's probably going to piss off a lot of sports fans.
No, but it is.
But it is.
That's-
Think about just a shot at a free throw. That's a parabolic arc that your basketball has to make precisely
Yep.
to go into the net.
Well, I mean, there's margin.
Sure, there's a margin, right? But like even still, like if you want to swish as opposed to hitting the backboard, which is an entirely different calculation.
Think of if the tolerance on the hoop was smaller.
Like just the thickness of the hoop itself. Yeah.
No, like literally, like the ball is 24 inches. The hoop is 25.
25.
Yeah. You got to hit it perfect at that arc.
But it's basketball was like an engineering problem that became a sport.
Yeah.
Right.
And I think that's crazy. If you think about it,
Golf.
like golf too. Yeah.
Yeah.
Think about it as like you were taking a cross section of the thing. You could just see the line segments.
Yeah, absolutely.
Or you can just see like you could triangulate your area or like the distance to the tee without necessarily knowing all of the dimensions because of physics.
Mm-hmm. But I think in the same like way that physics can predict a lot of things, I think the things that we can't predict are that much cooler, you know?
So anything dark, right?
I mean dark like or them smashing two atoms together at the speed near the speed of light, you know? We don't know what the gonna happen. We can't predict, you know? I mean, we can theorize, but we have no idea, you know?
Wow.
I would like to see. I don't know enough about CERN, but I'd like to learn more about it.
Absolutely.
CERN's the particle accelerator, right?
I believe CERN is the governing body that operates the particle accelerator.
Okay. Cool.
It's the Large Hadron Collider.
That's what I'm
is
thinking of,
you're-
yeah. Thank you. It's
Yeah.
the source of the Flash's power. I mean, what? No, that's wrong. He was doused in chemicals and electricity struck him.
And then he ran around it 5 times.
I love it though. Like there's a comic book. There's 2 more things I want to hit. One of them being what we were talking about before the show. Engineering is one of the most important jobs that needs to be fulfilled in a growing society. But that's what Garrett says is true. It's applied physics.
Yeah.
Engineers work out how to harness the laws of physics
How
for
is
them.
they're pre-predicting how this is going to work before you ever build a thing, you know?
Right.
You go, we're going to make it out of this material.
Right.
This material has these properties, you know? And that's all, it's physics on
Physics, math.
exactly. Applied physics, just add the math.
Yeah.
Yeah.
Quit talking to start numbers.
So when we talk about STEM, that's kind of one of the key factors of STEM. It's science, technology, engineering and mathematics. We need engineering just as much as we need new mathematicians, just as much as we need technological advances.
We need our engineers to build these things that our scientists or our mathematicians are figuring out.
To bring these theoretical things into life,
right.
To make these possible with the materials that we have, instead of just going, I have this idea to make this thing, but it's made out of this material that never breaks,
I mean, think about the last 100 years of scientific development. A lot of it's been in engineering.
Absolutely.
A lot of
material physics.
That too.
Like material engineering is insane these days. The different plastics and different levels of plastics, and
you know what might blow people's minds? Old blacksmiths are like the original engineers.
Yeah.
They just did it through like what is it, guess and check, though, as opposed to actually figuring out the science.
But I mean,
they were the first.
Science is done.
Well, they were still figuring it out, just in a different way, kind of. So.
It's what science is a guess and check. I have this guess. I do the thing. I make a check.
I guess I was going trial and error, maybe. Or whatever. Yeah. And the last thing, there's this comic book called Irredeemable, and they describe Superman's powers through the lens of physics.
That's awesome.
He doesn't. He's got a strong sense of telekinesis that he doesn't have heat vision. He excites the molecules in front of his eyes and then extends that excitement out.
Is that how he doesn't break Lois Lane's back when he grabs her at
it's not,
or flies with her?
That would be like he'd have to make tiny calculations to slow her down, right?
Well, he makes her lighter.
Well, it's Irredeemable is like an independent comic. It's not a Superman comic.
Right. Yeah. Right. It's not actually Superman.
Yeah. You're like solving the inertia problem or something.
I believe there is a book about the physics of Superman.
There probably is.
I wouldn't be surprised.
There probably is. There's probably multiple.
Yeah. It would be.
And then there's the one that's Batman always wins.
Yeah. Right.
Before we leave, we want to invite peer review. There's probably plenty that we got wrong, especially in that last 7-minute segment, but please let us know and correct us. Like that's part of science. Is peer review,
and we'll most definitely be talking more about physics in the future too. So
absolutely. Other than that, we will see you guys next week when we do something new.
Later.
Bye.